Hello, Algebra 1. Here's your practice problems for lessons 6 and 7. So here we go. Number 1 in lesson 6, select all the statements that are true. Here, B and C are going to be true. You'll notice over here, I actually took this function and graphed it in Desmos, and I encourage you to do that all the time because it just makes it easier to see what's going on. So for example, we can see now that, our starting point was right here at 3 meters above the water. In the equation, we see that right there. That's the part of the equation that does not have a variable. And then the function has one zero that makes sense in this situation, that is C. The zero in this function that makes sense is right here. The function technically has two zeros, here and here, but because in this problem, the x-axis is time, this zero would be over in negative time, which does not make sense. So this zero makes sense. And what it's telling us is that at a little over 2 seconds, that's when the diver reached the surface of the water. Looking at number 2, interpreting this graph, about when does it reach its maximum height, that's up there. It's just over or just under 2 seconds. So I did it about 1.8 seconds. Yours might be slightly different. About how high is the maximum height? Well, it looked like it didn't quite reach 60, so I did 59. Number 3, when does the ball hit the ground? That's at about 3.8 seconds over here. Again, yours might be slightly different than that, but as long as they're in the ballpark, you're good to go. Okay, in problem 3, hopefully you took those functions and plugged them into Desmos. You can see my graph down here. The red line is the graph of f of t, and I can tell because my starting point is at 4, and that's what this one is. And then the black line is g of t, and again I can tell because my starting point there is 5, and that's what is happening in that function. Also, something that's kind of interesting is that you can see f of t goes higher in the graph, and that makes sense because this part of your function tells you that starting velocity, or basically how fast was it shot upward. And this one was shot upward with more velocity than g of t, and so it makes sense that it went higher. But what we're trying to figure out is which rock hits the ground first, and g of t is the one that hits the ground first. I can tell on the graph right here. It hits the ground, or its height is now 0 at just under 1.5 seconds, whereas f of t is at about 2 seconds. In number 4 here, which object was launched with the greatest vertical speed? That would be B. This part, where you just have t with your term, tells you that initial velocity or initial speed, and so B has a greater initial speed, that would be 50. And number 2, which object was launched from the greatest height? That's A. This part of the function that doesn't have a variable with it tells you its initial value, and so 50 is going to be that greater height. In number 6 here, you're looking at the pattern of dots. Here's the table just based on what we see in those dots there. And then number 2, how many dots will there be in step 10? So I drew mine out. I noticed that I have a square forming right in here in each part or each step. And that square has a side length that's the same as the step number. So I'm going to have a square here in step 10. That would be 10 by 10. And then always there's 3 dots up here. And so in step 10, there's going to be 103 dots, 100 of them right here, and then plus 3 right there. How many dots will there be in step n? So here's my picture. Again, side length of n would be my square of dots, and then 3 more up there. And so in the square, there's going to be n squared dots, and then I'm going to add on those 3. All right, here we go in lesson 7, number 1. If you use the function up here to finish this table, this is what it would look like. And you're just trying to get an idea of what the ticket price should be. And it's a delicate balance because if you don't charge enough, you're not going to make much money. But if you charge too much, then no one's going to want to spend that much and they won't come. So number 2, for which ticket prices will the theater earn no revenue? Well, it's not on the table, but if they charged $0 for a ticket, then they're not going to earn anything. And according to the table, if they charged $50, they're not going to earn anything. Number 3, at what ticket prices should the theater sell the tickets if it must earn at least $3,200 in revenue to break even or to not lose money on the musical production? And here we would see that it would be between $10 because that's where they will earn $3,200. You could technically say it needs to be a little more than $10 or $10.01. That's perfectly fine. We're not going to get that picky here. And then looking at the other end of the table, where would 3,200 be in here? It's going to be somewhere between 30 and 45. And if you do a little trial and error, you'll see that at $40, they would make 3,200. And so your answer here could be between $10 and $40. This is building off of problem 1. It's kind of similar. Write an expression that represents the revenue in dollars from selling running shoes if a pair of shoes is priced at P dollars. And again, we want to find what is that sweet spot for the correct price. And so to find the revenue, we would take what the, or how many pairs it thinks it's going to sell, that's this, times the cost for each pair, that's that. And if you multiply all that together, that would give you the revenue. Okay, here we go. Number 3. Correct answers here are going to be B, D, and E. Looking at B, if the price is $5 each, then we're going to expect to make $800. Now this is worded as how many mugs are we going to sell? Well, if we make $800 and they're $5 each, 800 divided by 5 is going to be 160. D, the school will earn about $1,000 if it sells the mugs for $10 each. That's right here on your graph. And E, the revenue will be more than $700 if the price is between $4 and $14. So that's looking at this part of the graph right here, everywhere where the revenue is above $700. And number 4, if you look at this, your equation should end up being y equals 2n squared. And the way I saw this was finding my n squares, or finding my squares. So right here I have an n squared, and then there's another one of those right here where n is the same as my step number. Right here I also have 2 squares with sides that are the same as my step number, so there's my 2n squared there. And it also works down here at step 1. Is the relationship quadratic? Yes. It's quadratic because we know, or we see that n squared piece in there.